All right, taking a look at numero dos. That means number dos for those of you who don't speak Spanish. That's right. An 85 kilogram fisherman jumps from a dock into a 135 kilogram rowboat, which is at rest on the west side of the dock. If the velocity of the fisherman is 4.3 meters per second to the west as he leaves the dock, what is the final velocity of the fisherman and the boat? Okay. So,
85 kg max.
so that's so for whatever reason, we're going to the west. Let's, for the purposes, again, you can establish any coordinate system that you want. You truly can. As long as you're being consistent with the sign conventions that you choose at the beginning, you will end up getting the right answer. So just for giggles, let's have west be the positive direction. I know that'll make some people mad who are a little bit on the OCD purist side, but you know what? All right, so what are some things that we know here? We have the mass of the, all right, fishman. How much? Oh yeah, 85 kilograms. What else do we have? We have the mass of the boat, right? Yeah, rowboat. 35. And then we had the velocity of which one? Of the fisherman? Of the fishman.
I like the fact that like both like 22 like paddles is like a V8 car.
I have no idea what that means, but I appreciate that you appreciate
It's
it.
like a rowboat.
Oh, oh V8. Okay, yeah. It's an 8-oar boat. Am I spelling this right? Initial? Did I spell that wrong?
It's an H for make humans. Maybe for humans if they're just really strong.
Okay, so is that all we know? So we want the final velocity of the fisherman and the boat at the end of the jump, right? Because he's jumping in. So the total momentum before is going to be the mass of the fishman multiplied by the velocity of the fishman plus the mass of the boat multiplied by the velocity of the boat, which actually ends up being pretty simple to take care of because the initial velocity of the boat, 0, right? So this entire part actually disappears even before we get started. So all I'm actually doing here is 85.0 kg multiplied by, what was it, 4.3 meters per second. Okay. So that's my initial velocity.
Division or an addition symbol on the line.
Where are you looking? Right here?
Yeah.
This one is a addition.
Yeah, which line?
Fair enough. All right, so this ends up being 3. Whoa, 6, 5.5. I'm running out of room here, guys. So
For the aesthetic.
yes, yes, you guys are worth it. All right, so we have the total momentum before. Now we can set up for the final total momentum, which we talked about this the other day in class, that if I have a situation that looks like this, and that situation, we talked about this situation in which if the two objects, right, the two different masses, they come together and they stick together as one mass, kind of similar to what's happening with this fisherman jumping into the boat. You can now treat that one object as one object, right? Even though it's two different masses, they're actually touching, right? They're together. And so what this ends up being is, in the final analysis, right, for the final momentum calculation that we're trying to do here, we can actually say that both objects are moving at the same velocity, right? Because if you are in a boat, you are moving at the same velocity as that boat. And so we can change that to look like m1v plus m2v, because they're the same velocity. Well, if that's the case, I can actually factor that out, and I just add the two masses together. And this will actually allow me a setup for my calculations where there's just one final velocity to solve for. A lot of students they keep those two different velocities in there, and it's hard to solve for two different variables. But if you factor it out in this way, things end up being quite a bit nicer. Quite a bit nicer. So I have my setup for the final momentum. So that's going to be mass of the fisherman plus mass of the boat, and then final velocity. All right, so final velocity is going to be the what I have over here, right? The initial. Which is equal to 65.5. G plus the mass of the dude. Ends up being it's 220. Now, with the way I have this set up here, notice how there's a kilograms times meters per second, and I'm dividing that by a kilogram. That means that in the final calculation, the kilograms cancel out, so the only unit that I have left is the meters per second, which is what should be happening because I'm calculating a velocity here, and my calculator tells me that that should come out to be 1.66 meters per second.